All right, so this is quiz question number 2, or test review question number 2. A coffee machine dispenses coffee into cups. You're supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. Here are the amounts measured in a random sample of 20 cups. All right, you may assume that the amount of coffee that is distributed follows a normal distribution. They needed to tell us that because our sample is less than 30. And then they say test at alpha equals 0.05 to determine whether or not the machine is underfilling the customer's cups. So they say test, so this means they want us to run a hypothesis test. Well, first off, let's be really careful. In the previous video, we were running a paired test, and we had 2 rows of data. And we're like, hey, this looks very similar. But please remember, in the first video, we were testing the kid's hand twice. We're testing them once with the outside for lead and the inside for lead. Here we're not doing that. Nothing is being tested twice. We're measuring 20 cups, all right? We're not taking 10 different cups and testing them twice. We're testing 20 separate cups. So this is a 1 sample T. So this is not a pair, this is a 1 sample T. Nothing was tested twice. Again, I'm making the distinction. Here we tested something twice. We had an outside or an inside or before and after situation. Outside, inside tested twice, before and after. Over here, we're like, hey, we're just selecting a group of 20. And so we know that N is 20 and there's nothing, it's not 10 pairs. This is just 20 cups of coffee. So we're running a 1 sample T test. And we need to start off by writing down our null and alternative hypothesis. Well, the claim is we're supposed to be getting 10 ounces. So we're going to start off with, that's our null, HO. The mu is we're getting exactly what we're supposed to be, because you remember it's like the court of law, innocent until proven guilty. So until we have enough evidence, we're going to believe their claim. It may or may not be true, but we're going to believe it till we find otherwise. And then we have mu, and then we need 10. We need to figure out what is our inequality. So when we look at this, it says to test at alpha equal 0.05, determine whether or not the machine is underfilling. Oh, we're worried about it being less than 10 ounces. All right. The next thing we need to do is define the parameter. Well, our parameter is let mu, and notice this is not mu d, this is mu because it's a 1 sample. So let mu equal the true population mean. And notice I didn't write the word difference. Well, I didn't, you don't see a D there, so I don't need the word difference. When we were doing the paired, we had a D for difference, so I need to include difference here. Here I don't. So let the true population mean amount of coffee. All right. Let mu equal the true population mean amount of coffee. Really, it's true population mean amount of coffee in the cup. All right. Conditions for our class, they're assumed. So we can always just go with that. The next thing is write our equation. Well, notice I don't have a D in there, so I'm just going to use the standard T equation. T equals x bar minus mu S over the square root of n. T equals x bar minus mu S over the square root of n. The next thing that the recipe says is enter our data. All right. Well, I've already done that, so I'm going to go to stat edit. And if you'll notice, I have all this data entered in L1. I want to remind you how to clear out columns. So I'm going to clear out these columns that I don't need, which are L2 and L3. So I just arrow over to L2, arrow up so that it's highlighted, press clear, then enter. arrow over to L3, press clear, then enter. So everything's cleared out. All right. So you'll notice that I have all my data entered in L1, 9.9, 9.7, 10, and all the data is entered into one column. All right. Next thing, step 5 says find XD. And really, I want XD, I want N, I want all these things, right? So here's the way I do that. And I shortcut this. I go stat, test, and this is a t-test. All right. And what makes this the t-test is I'm having to use the standard deviation from the sample. They didn't tell me the standard deviation of the population. I'm having to calculate it from this. So stats test, t-test. I'm using data. Well, my mean in this case is 10. All right. My mean in this case is 10. My list is an L1, so I'm going to press second one. And my alternative was a less than, so this needs to be a less than. And I'm going to press calculate. And when I do that, I end up getting a bunch of information, but I'm going to start off by writing my list of information, which is X bar equals, well, first off, we're going to start with X bar equals 9.845. All right. My standard deviation is 0.1986. My sample size, I had 20 cups of coffee. I was very thirsty that morning. So my N is 20. And my degrees of freedom, which I just want to get in the habit of writing down, is 20 minus 1, which is 19. All right. Okay. So I also have some other information that I'm going to write down because I'm going to use it later and I can refer back to it. So T equals negative 3.490. And I also have a P value equal to 0.0012. And we'll come back. We don't need this right now, but we'll come back to that. But I need to plug this into that equation. So I want the probability that T, and I know that this is going to be a less than because this was the last less than symbol. T is less than 9.845 minus, well, what was my mu? Oh, that's my mu because it's 10 ounces. All right, my mean is 10 ounces over 20 divided by, excuse me, not 20, 0.1986, my standard deviation, divided by the square root of 20. Probability T is 9.845 minus 10.1986 over the square root of 20 equals, I told you we would need this, equals negative 3.490 equals the probability that T is less than negative 3.490. So there's my T statistic, equals 0.0012, and there's my p-value. So there's my p-value. I need to look up my alpha. Well, they told me earlier they use an alpha of 0.05. So here's 0.05. Always make these the same number of decimal places. So if this is 4, this is 4. And 12 is definitely less than 500. So this is less than. And remember, if we look at our recipe card and we have a less than, we're going to reject the null. All right, we're going to reject the null. So our p-value is 0.0012. We reject the null. There is sufficient evidence at alpha equal to 0.05 to suggest that the true population mean amount of coffee is less than 10 ounces. Oh, we just says it is less than 10 ounces. So that means, in simplified terms, the machine is underfilling. So there's our simplified terms. The machine is underfilling. It didn't ask us that. We should get in the habit of writing down simplified terms. So the machine is underfilling. All right. So that's part A. Part B says, construct a 95% confidence interval. Okay. So I'm going to start off by rewriting. I'm going to start off by rewriting the parameter, which is let mu equal the true population mean amount of coffee. Okay, so now that we've done that, the next thing we need to address are the conditions. And in this class, the conditions are always, so that's number one. Number two, the conditions are assumed. And notice this says mean amount, not mean difference. Why? Because this is a one sample. This is not a paired. All right. So assumed. So number three, we need to write down our equation, which is x bar plus or minus t star s divided by square root of n. The next thing we need to do is enter the data. Well, we've already done that. So since we've already done that, let's get our information, because remember we have our data all entered in L1. We already did that. So let's go ahead. And once again, I like to shortcut this, and I get this information quickly, and I go stat test, and I'm going to go down, drop all the way down to t interval. So I'm going to scroll down until I get to t interval, which is number 8. I have data. My list was in L1, so second one. And I want a 95% confidence level, 0.95. Oops. Frequency should be 1, confidence level 0.95. And so I get more information than I need, but what I have to start with is I need x bar equals to 9.845, s equals 0.1986, n is 20, which means my degrees of freedom are going to be 20 minus 1. And then it also gives me my interval size, which is 9.752 to 9.938. So this is my lower bound, and this is my upper bound. All right, so there's my lower bound and upper bound of my interval. We'll come back to that in a moment. So now that I have this, I'm going to start plugging this information I have into my formula. I'm going to go 9.9845 plus or minus, and I notice I'm missing T star. We'll come back to it, but we're going to have to go calculate T star. So I'm going to add that to my list of things that I needed. And I have S is 0.1986. and N happens to be 20. But I need that T star value. So how do I go about getting that? Well, I'm going to go to my calculator, clear the screen, and go second vars, inverse T. And my area is going to be parenthesis 1 minus, well, my confidence level was 0.95, 1 minus 0.95, close parenthesis, divided by 2. And degrees of freedom, well, my sample size was 20, so 20 minus 1. And that's just the same as 19. So if I wanted to, I could just type 19 there, and that'll work just as well. My degrees of freedom are 19. And I get T star, and always make your T star a positive. So this is going to be a positive 2.093. Well, what does that equal? Well, that equals my interval. So when I've done that, my interval is now 9.752, comma 9.938. So here's my lower, there's my upper. And so we have that part of our job done. And as I look at the question, it's like, okay, we did that. Well, anytime we calculate a confidence interval, every time we do a confidence interval, we have to write the conclusion. So our conclusion is that we are 95% confident that the true population mean amount of coffee. And I know you're going, where did you get that? Where did I get the true population mean amount? That's what we define as our parameter. True population mean amount of coffee lies within the interval. And what was our interval? 9.752 to 9.938. 9.752 to 9.938. So we're 95% confident that it lies within that interval. We're like, yay, great. Well, if we notice on our recipe card, sometimes it says, explain the meaning of the confidence level if asked. Well, did they ask us? And explain the meaning of the confidence level. So that means when we get to do the in repeated sampling. So in repeated sampling, we expect to capture the true mean amount of coffee 95% of the time. Okay, so in repeated sampling, we expect to capture the true mean amount of coffee 95% of the time. So now we've go back to this and we've done all right. We did the hypothesis test, that was part A. Part B, we constructed the confidence interval and we defined the confidence level. Then it says, based on the confidence interval, what's the lowest plausible amount of coffee? Okay, well, the lowest plausible amount of coffee, which was question C, well, that's the lowest bound of my interval. So the lowest amount of coffee is 9.752 ounces. Yay, part C was fast. Part D, based on the confidence interval, what's the highest plausible amount? Oh, well, the highest plausible amount would be the highest part of our interval. So 9.938. And notice 10 ounces does not lie in the interval. 10 ounces is above it. 10 ounces is up here. It's not contained in that interval. So part E says, is the confidence interval consistent with a hypothesis test? All right. So first off, what does the interval say? The interval indicates that there is less than 10 ounces of coffee because the interval is below 10 or lies below 10. And we were like, yeah, the interval is definitely below 10. It's not contained in there. So the interval is less. Well, is that consistent with the hypothesis test? What did we say on the hypothesis test? We said the machine is underfilling. So guess what? The interval and hypothesis test are, the interval and the hypothesis test are consistent. All right, so the two of them agree. The interval and hypothesis test agree. All right, so that concludes the second one. And the next video will have the third question.